Hi, today we are going to talk about Python variables and data types. We are going to use Python Trinket for some live coding that we are going to do during this discussion. So let's get started. Here are our lesson objectives. We'll define and use variables. We'll identify data types, follow naming conventions and best practices, convert and manipulate data types, and apply that knowledge to hands-on coding. Now, before we go over the formal definitions, let's do some live coding. Okay, so a couple things we need to know for running any Python program. Well, of course, I can just do this. It will not do anything, right? I just say x equals 5. So what I have to do here is x equals 5 maybe, or just get started with this print. So it prints hello world here. This is the way I wrote it there within two quote marks. If I just add an exclamation mark, it'll be printed as is. So what we have inside this two quote marks is called a string literal, which is a string of characters or English letters with some special characters like exclamation mark. So whatever I write here, it'll be printed as is when I run this code. So let's try this. Yeah, it'll just print Python, but if I say Python like this, so it didn't work. So the reason is that Python has some reserved words that we cannot use like that. Anything you put within quote marks is fine, but without quote marks, when you do, you can you can do certain things you cannot do. So if I just do this, it'll work. It will not work. So Python has certain keywords or reserved words that you cannot use the way they are in Python. So you have to remember that. And also another thing is that if I start something, a line, a statement with hash, that means that is a comment. That line will not be executed when the program is run. So it'll just for explaining things for descriptive purposes. You want to say what you meant to do in the next line when it is necessary. So let's try to run this. It'll not run. Yeah, it did run. Okay. So now the next thing is variable. So in Python, I can do this, x equals, say 5, y equals 3.14, and then z equals x plus y. And then I can say print z. Let's run it. So essentially, x and y are variables in Python. Just like they're variables in algebra, there is no difference so long as numeric data types are concerned. In Python, you can do the same thing that you do in algebra. Of course, with the limit of size, because you can use very large numbers, but within the limits of what Python can actually accommodate in the computer that you're working with, which is very large. We don't have to worry about the size right now, but it is not infinite. It's a limited amount of space. Now, what is different in Python is that a variable can take non-numeric values. So let's try to do this. Say and then say. So you cannot do arithmetic operations on them, but the string literals, but or the variable type string, but we'll talk about it later. Now let's go back to our slides for a bit. So let's see. Yeah, this is what I was talking about. We already covered that. It's a Python variable, just like a variable in algebra. Now, inside the computer, the variable is really a location in memory where you store a certain variable. In algebra also, a variable is a placeholder. So you can assign 5 to x, 6 to y. And if you say z equals x plus y, the summation, the number that you get by adding x and y will be stored here. Now, if you change x to 2 and y to 3, then these values will change, but this equation here, it remains, oops, sorry, remains what it is. So now we also talked about it. Python variables can take string literals, non-numeric values, unlike algebraic variables. Now this is another thing. So Python variable can take all kinds of values, but definitely they need different kinds of memory allocation for storing those values. So it will take different amounts, even different types of memory allocation for storing all three values, 5 and Python and 3.14. So in some programming languages, you first have to declare the variable, like it is int x. In this case, I try to do. So this means that x can take only integer values, and you can assign any value only after you declare the type of the variable, or in short, declare the variable. But in Python, you don't have to do that. Just saying x equals 5 is enough, and Python will figure out what data type it is. So you can assign these values to a Python variable. Now note this none. None doesn't mean 0 or empty string. It just means there is no value, no value. So you can assign anything so long as the data type is allowed in Python. If you just come up with something that is half string, half numeric, that may not work. Okay, so we can categorize variables in Python in different ways, but this is something also, we haven't discussed this yet, but this is pretty obvious. The amount of space you need for storing just 5 versus the amount of space that you need for storing 3 numbers, 5, 6, 7, a list of numbers. Python actually has a data type called list. So it'll need different kinds of memory allocation. Now, Python variables can be categorized in many different ways. Python has something called a function, and then we have global variables that is shared by all the functions in a Python program. There are local variables that belongs only to a given function, but we'll not discuss all those things yet. We can categorize variables in another way. When you print something, you are outputting the value of the variable to the computer screen. And when you use input, you're accepting input values for a variable from your keyboard. In that case, it's an input variable. So we just briefly discussed those, but we will not discuss it any further in this lesson. Here we'll categorize variables based on data types only. So based on that, there are two kinds of variables. One is primitive, that holds a single value, and non-primitive, that holds a multiple values, like a list of values. And non-primitive always have multiple values, but they need different amounts of memory and different types of memory because they may have to store the values in a certain way. We'll get into that soon. Now so data types can be of two different types that any variable can take in Python. One is built-in data type that comes with Python. You don't have to do anything for using it. When I say int, a variable is of type int, I don't have to define what int is, but users can also define data types, and then they can use it. They exist in Python. You can do that in Python, but we'll not talk too much about user-defined data types here. So all user-defined data types are non-primitive, but Not all built-in functions are, I'm sorry, not functions. Variables are primitive. They have primitives and non-primitives, both. Now, here are some examples. We talked about int, float, string, none. We haven't talked about bool. Bool is Boolean value. Bool is a variable that can take Boolean value like true or false. For example, if a variable is called isStudent, if you say isStudent equals to true, that means that is true. And if it is false, then it is false. In that case, whoever that variable is representing is not a student. So there are more built-in data types in Python. Those are non-primitive. In the previous list, only string was non-primitive. Rest all were primitive. So actually, none can work both as primitive and non-primitive, but rest all are primitive. So here there are different kinds of non-primitive data types in Python. One is list, one is tuple, list is just a list of variables, variable values actually. These are data, not variables. So list and tuple, they look very similar. There is a reason there are two kinds of lists in Python. One is list, one is tuple. Actually, let's do some live coding to show that. Show the difference between list and tuple, actually. Okay, so I can say, so I don't want this first print statement now, so I can either delete it or put a hash in front of it. That means it's commented out. We don't need it anymore, and then it will not run, but we can uncomment if we need to. So let's create the list. And now, when I try to print the first element of X, we do it with 0, not 1. That's because lists are zero-based, lists use zero-based indexing in Python, but we'll not get too much into that yet. Let's see what happens. Okay, so let's do this. Okay, but if I try to do like something like, so this will not work. So what this means is that Python has two different kinds of variables. One is mutable, one is immutable. One is like you cannot change it after you create it. And another case, you can change it after you created it. So list is mutable and tuple is not mutable. Actually, string is not mutable either, but we'll not discuss it too much now. We'll discuss it in other lessons. Now, here is a little quiz. If you want to test your knowledge of what you have learned so far, you can answer them, you can check the answers, but you can also try to run that and see what happens. Actually, there is a way to find the type of a variable. We'll talk about it later. So far, we talked about types of variables that's allowed in Python, types of data that's allowed in Python. They are connected because when you assign value to a variable, the variable's type is the same as the type of the data. Otherwise, there will be error. But in Python, you don't even have to worry about it because Python determines the data type in runtime when the program is run. It's called dynamic binding or dynamic typing. Just so that you know the name, but you don't have to do anything about it. Now we'll talk about naming conventions of variables in Python. Now, any language has grammar. So Python is a language. For programming languages, grammar is syntax. So there are certain syntaxes are just rules that you have to follow. when you want to define a variable, name a variable. So these are just like variable name has to start with letter underscore. Variable names can only take alphanumeric characters, and variable names are case sensitive, which is important. So AGE all lowercase, AGE mixed case, and AGE all uppercase. They're different variables. They're not the same thing. And obviously you cannot use Python keywords as a variable name. Now here is also a quick knowledge check. You can try to determine which one is a valid variable name and which is not. You don't need to memorize it all right now, because when you become fluent with the language, it'll come automatically. So, but you can try to figure this just for practice. Now that was naming conventions. Now there, well, actually, these are best practices. We talked about what you have to do. This is something you don't have to do. If you just use S instead of student name, the program will still run. It'll work the same. But the difference is that when you read the program at a later time, you yourself may not know what S meant. It is more descriptive if you say student name, then you will know what the program is trying to do. Even without reading the comments, it will make some sense. And so it's all about readability of the program. There is another example, total price, where you see an underscore, you say an underscore in student name. So the idea is that if you use an underscore for a variable name that is made with more than one word, just separate them with the underscore so that it's more readable. And in Python, the convention is that you use all lowercase with underscore where you need to. Here are some more examples. Now, this is something I was talking a little while ago. So since Python uses dynamic typing, you don't determine the variable type explicitly before you assign the value. At a later time, you may need to find out the type of the variable. Now, it kind of looks pretty obvious. Age is int and price is float and message is string, but it is not always so obvious. So there is an option for finding the type of any variable. Is the type function right here in the first line. So when you run that, you see that the result is class int, the word class. It is always class because Python is an object-oriented language and pretty much everything is done with a class. But for now, you can ignore class. And what you're looking for is what appears after class, like int, float, str for string, and so on. Now, another thing is there in Python, which is called type conversion or typecasting. So say here you assign num equals 10, 10 is an integer. Now then you can cast it to a string. So we could have named this variable name also, but name underscore str is more descriptive. So you pass this variable into this function called string, and it gets converted to string. You can convert it to float also, but the point is, why do you even need to do this? So here's an example. When you say user age, you get the input, enter your age. Whenever you input a variable from keyboard into your program, it goes as a string. So in next line, you try to say that next year you will be user age +1. You cannot do this +1, add 1 to a string. You use this plus sign in connection with strings, but that is totally different. What you do, this will produce error. So maybe let's do a little coding here. So I say print. And then it is error, it's not going to work. But if I do this, cast this into int, I have to come here and then enter. Okay, so it works. Now, okay. So just remember that we use this plus operator for strings also, but that's not about adding the values. Okay, so we can reassign values to a variable. I can start with x equals 10, and then I can say now I am a string, and x will become that, 10 will be erased. We can assign multiple values to multiple variables in one line that we cannot always do in other languages. Now here's an example of multiple assignment. Maybe let's do that again. So if we have to swap values of two variables in any other languages, say x equals 5. Now, sometimes we tend to do this, x equals y and y equals 6. This will not work because by the time we're in line 12, I'm sorry, line 9, x has already become 6 because we made x equals y. And then when I say y equals 6, both will become 6 because 5 is erased. So what we have to do in this case is have a third variable, temporary storage, temp equals x. It will hold the value of x. Then I'll do x equals y, and then y equals temp. Oops, what did I do wrong? Oops, still temp equals x. Temp equals x. Oh, I still retain this. That's creating all the problem. Yeah, it should have worked. Okay, so a real world example of this is game leaderboard when you want to switch places for people that is represented by a variable. So we can write a program that takes student name, age, and favorite subject. And that is how websites store their user information. Let's try that. And what should be, it should be input. Not here. Yeah, so see how it works and what the plus sign does for strings. So it just concatenates strings. And see, things appear just like I spelled here. So I spelled history with a lowercase h and it was printed like that. So there's no correction or anything. It will just print whatever you enter here. Okay. So just recapping, variables are those stored data in memory. There are different data types that exist in Python. And of course, the variables are of the types of the data that they hold. Python supports dynamic typing and type conversion, and variable naming convention and best practices increase readability. This is an assignment. You can build a shopping cart. So it's sounds a big project, but it's not. You already have what it needs for doing this project. Ask the user for 3 product prices, store them in floating point numbers, and calculate and print the total cost. If you want, you can convert total price to an integer. I don't know why anybody will want to do that for rounding off or just for practice. Here is a chapter quiz that you want to do to check your understanding. And the good thing is that if you don't have the answers, you can just try to run this in a code editor and you will know what you thought is right is really right, whether it works or not. So it's time for QA. Unless there is any questions or anything, I'll just stop here.